So let's move on to factorising. First thing you always do is look for a common factor. It's the easiest form of factorisation it is. It's also the most commonly forgotten one. But draw that out first. Once you've done that, the number of terms that are there can give you a hint as to how to approach it. So if you've got two terms, well, at this stage, the sort of thing we're looking for is, well, is it a difference of two squares? Is it one of those sort of things? Maybe it's the sum and difference of two cubes. We'll talk a bit more about that later. If there's three terms, well, the sort of expression we see with three terms is one of those quadratics, or quadratic trinomial. So can we do it using those techniques? Four terms really is looking for a common factor, but we just do it in pairs. And then once we group in pairs, it becomes two terms, and then we go from there. So they're the sorts of things we look for first when we're trying to factorise. Oh, obviously there are other ways of doing them, but they're sort of the key ones. So okay, let's do some examples of each of these. This one will blow your mind. Common factor. Remember, when you're factorising, it simply means divide by the common factor. So you're dividing every term. The reason I say that is sometimes when we're doing it, people go, well, hang on, what's left in the parentheses? But if you think about it, all you're doing is dividing, then it's quite, I hope, easy to work out what's left. What do they have in common? Tricky. Yes, indeed, it's an x. We get x outside a plus b, so all right. 5x squared minus 10x, the reason I put this one there is to highlight sometimes we only find one. Keep searching. Because some people would look at that and go, oh, look, 5's a common factor, you beaut, away we go. But then, of course, they have to do another step. Someone else might go, oh, look, x is there, you beaut. If you can spot both of them in one, it's going to be quicker, of course. So 5x is, of course, the common factor. Four terms, but this is what I was saying, it really is finding a common factor. You see something like this and you're going, right, something they've all got. Oh, excellent. The first two have got x, x, x. Oh, damn, no x. Oh, hang on, two of them have got m. Oh, but the others don't. Oh, what about the one? Ah, damn. And then it just doesn't work. So we do it in pairs. It really doesn't matter which pair you pick. I mean, if it doesn't work, you just try another pair. So I think I did the logical way of just choosing the first two. The first two, x is a common factor, m minus n. So I would like the second pair to also have m minus n, which is why I take out a negative common factor rather than a positive common factor. Now, I've got two terms. The common factor is m minus n, so of course it becomes m minus n, x minus y. Okay, difference of two squares. It really is just the reverse of our formula for expanding out, because it's going back the other way. So if we notice 16x squared minus 1, oh yes, they're both perfect squares. Fantastic. So we get 4x minus 1, 4x plus 1. Does it matter whether the plus goes first or the minus goes first? Not really. But which way is the logical one? Which one's the logical one? By the way, there's a huge hint right there. Oh, well done, yes, the minus first is the logical one to go first. Hence why I did it that way. 3y squared minus 75, you look at that and go, oh no, they're not perfect squares. But that's because I forgot the first rule, common factor. Always look for the common factor first. There is a common factor of 3. We get left with the perfect squares. And there we go, 3 outside of y minus 5, y plus 5. Oh, here's another one with 4 terms. Okay, group in pairs. See how we go. 5x minus 5y has got a common factor of 5. X squared minus y squared. Well, that's okay, because now we combine it with the idea of difference of two squares. And so the second pair is x minus y, x plus y. They have a common factor now of x minus y. So we can pull it out. What's left, and this is the sort of one I was talking about, that something like, oh, hang on, what goes in the second one? Just think, I'm just dividing by the x minus y. Divide the first one, we get 5. Divide the second one, we get plus x plus y. So plus x plus y. Right, let's move on to our quadratics. We'll start with the easier ones, the monics. It comes from this idea. Right? If we were to expand out the factorised trinomial, we would get x squared plus a plus bx plus ab. And that's why when we look at these, we say to ourselves, oh, what multiplies together to give this number? What adds together to give the other? Because then we can recreate what we have there. Okay, so we look at this one. What multiplies together to give 18, adds together to give 9. Now, clearly we're looking for two positive numbers because they multiply together to give a positive number, but they also add together to give a positive number. What would it be? What would it be? 6 and 3, of course it is. X plus 6, X plus 3, or if you prefer the other way around. Doesn't have to be X, of course. Multiplies together to give 3, adds together to give negative 4. So in this one, we know it's going to be two negatives multiplied together because they multiply to give a positive, but they add to give a negative. Multiply to give 3, add 4. Oh, 3 is a prime number. We haven't got, oh, it's lovely when it's prime numbers, isn't it? Because there's not much choice. 3 and 1, t minus 3, t minus 1. Whoa, it's got y's in there. Well, it doesn't matter. The rules are still the same. Just ignore the y's. Or if you prefer, ignore the x's. It doesn't matter. Just make sure you go, well, which one am I referring to? And that's the way I'll deal with it. And as it's x squared as opposed to 4y squared, I'm going to treat it in terms of x because a monic is always easier to factorise. So here, technically what we're saying is what multiplies together to give 4y squared but adds together to give minus 5y. But that's what I mean. You don't have to worry about the y's because the numbers are what we're interested in here. Multiplies to give positive, adds together to give negative. So we're talking about two negatives again. And, oh, okay, so it's the logical one, 4 and 1. Isn't it? But then when we put it back in, instead of going 4 and 1, we say 4y and 1y. Well, why? But what if it's not monic? There are different ways of doing monics. Probably the most popular method, not with me myself, but is that, that cross method? Yeah. Is that the one you've been using all these years? Good, they've been training you well. We've been doing split in the middle? Very good. Because to me, this is a much more logical way of doing it. This is the way I prefer. Splitting the middle, why? Because it keeps the same thought process as the monic. The difference being, we don't just multiply by to get the 7, or the negative 7, we have to also multiply by whatever the coefficient of x squared is. So we're going to say what multiplies to give minus 21. And adds to give 4. Now in this case, we know one's a negative, one's a positive because they multiply to give a negative. They add together to give a positive, therefore the bigger number must be the positive number. Multiplies 21, difference of 4, 7 and 3. But the bigger one has to be the positive. So we physically split the middle into those two terms. It becomes a grouping in pairs question now. So first two pair, 3x, x minus 1. Second two, 7 outside x minus 1. Pulling it together, x minus 1, 3x plus 7. If there is anyone here that hasn't used the splitting the middle method, then when we are doing the exercise, have a go at it. It's like I was saying the other day. You know, yes, you're comfortable with one way, but try another way. You might like it, you might not like it. Up to you eventually how you end up doing it. But for the sake of the exercise, try something new. If it is new to you, do another one. So for this one, multiplies together to give negative 24, adds together to give negative 5. So it must be a negative times a positive. This time they add to give a negative. So the larger number in magnitude must be negative. Factors of 24. What we got? 8 and 3, isn't it? That's got a difference of 5. Yeah, 8 and 3. So let's split the middle. Minus 8 plus 3. Group in pairs. Finish the factorisation. There's our answer. Okay, there's our first bit of theory for today.